Good afternoon and welcome. My name is Mickey Fitch and I'm in my final doctoral course before the Thompson dissertation process in the Leadership in Higher Education PhD program here at North Central University. I'm happy to have you attending this presentation today where we will talk about experimental design. In the overview of this presentation, we will cover a variety of topics. First, we will discuss what experimental design is and what makes it valuable in scientific and educational research. Second, we will understand randomization and the different types of randomization in experimental design. Third, we will analyze 3 sampling methods used in experimental design and their applications in real research. Experimental design is noted by some researchers, such as Mertens, as one of the only true and pure research designs because the design is able to establish cause and effect. Experimental design has clear independent and dependent experimental variables and very specific conditions under which variables are manipulated to observe and comment on changes in effect size. Samples are organized into treatment or experimental groups and control groups for the studies. Because of the specificity of design and the ability to exactly manipulate variables in the design, many utilize this approach to understand and create evidence-based practices as outcomes of this research style. There are, however, limitations within experimental design. In many social science contexts or educational contexts, experimental design cannot be utilized because of the lack of randomization inherent in the population and structure of school systems, organizations, and communities, as noted by Mertens. There are 3 main distinguishing elements to experimental design that I will focus on here. First is randomization. Randomization is a method used for sampling from your population. Randomization and true randomization means that every participant has an equal chance of ending up to be a member of the control or treatment groups. Mertens, 2005. As noted previously, this can be challenging to achieve true randomization in situations in which social classifications, such as grade levels, or other factors such as gender, age, sexual orientation, and ethnicity cannot be randomized. Second, experimental design has both control variables and treatment variables. The treatment variable, also called the independent variable, is what is manipulated by the researcher to determine if there are changes or effects. The dependent variable is, as one may guess, dependent on the other variable to see if there is an impact of any sorts. Controls and treatments are held steady and manipulated to determine if any significant effect exists. Significance is a statistical measure to show if there is a major change of any sort based on the experimental conditions. Effect size, in short, helps the researcher understand the extent to which any significance exists. Lastly, internal and external validity are important to experimental design. Internal validity helps researchers know that the manipulation of the variables is what caused the effect, not some other factor or variable. Mertens, 2005. External validity, on the other hand, is the degree to which the results are generalizable to other contexts and situations. Internal validity is the notion that the changes or effects seen are as a result of the treatment of the participants experienced. Mertens, 2005. 3 main threats to internal validity and potential solutions are A. Testing overload, where participants can become over-tested or get used to the testing and their results change positively or negatively because of it. B. History, where participants can remember items from a previous testing period and implement them currently not as a result of the treatment. And C. Maturation timeframes, where the study is done over a time period where there are developmental or maturation changes in the participants. Threats to external validity are instances where there are outside concerns or potential effects that contributed to the results and not necessarily the treatment variables themselves, such as Ongdeen, Hofstetter, and Strick 2011 explained. A lack of external validity would mean that the results of the study would not be able to be generalized to other studies or populations. A few potential threats and corresponding solutions to external validity are, as Mertens and Trochim noted here. First, the researchers need to make sure the variables and conditions are explicitly defined and specific enough for other future researchers to replicate. Second, the researchers need to ensure that the treatments that they impart in the study are few enough that it can be clearly noted that the outcome is a result of the treatment. If there are too many possible treatments, it can be difficult to clearly state and determine that one treatment caused a particular effect. Third, a threat to external validity can be the novelty or uniqueness of participating in a study. This can sometimes alter the way in which a participant would function or normally participate, so researchers need to make sure that the reduction of novelty occurs. Lastly, treatment effects can be exacerbated and thus a threat to external validity if the participants become sensitized to the treatment itself. As Trocum 2012 noted, random selection is about the participants and the selection process. Random assignment, on the other hand, refers to the design itself and whom amongst that sample gets what treatment. While it can be easy to confuse the two terms, it is important to keep in mind that the selection itself comes as a product of design. Your sample is related to the population in which you want to study, therefore you are most concerned with external validity and how results can be generalized to a larger population. Your design itself is most related to internal validity, as you want to make sure the assignments you make clearly can be noted in the results. Not only can a discussion about internal and external validity help reduce uncertainty and potential error, but there are several additional methods as noted by Trocum 2012 to help reduce potential error. First is concept mapping. Strong researchers detail their investigatory journeys not only to create good design, but also point out potential flaws. By engaging in concept mapping, the researcher is able to poke holes in their own design, determine potential correlation and causation elements, and also move forward towards generalizability. Second, engaging in strong sampling methods will ensure that the population being studied has been selected in a truly randomized fashion and has been assigned to groups in a randomized fashion. Ongdeen et al. 2011. Making sure there is a clear understanding of the sampling criteria, ways in which the population is informed about the potential for participating in the sample, and engaging in bias-free sampling procedures are key for the reduction of uncertainty and error. It is important to understand a few key sampling methods as they relate to experimental design. While there are many different options, I have chosen 3 to explain here. The first is systematic random sampling. In this method, the researcher would select the first participant and then determine some sort of interval to select the participants from into the future. For example, a researcher would select the 5th person on the list, then the 10th, then the 15th, then the 20th, and so on. This method is part of probability sampling, as noted by Rall 2017. A second method of probability sampling is cluster sampling. In cluster sampling, a researcher may be looking to gather a larger population of participants, but they may not be able to all have the same kind of access to the study. This would be the case in geographical limitations. If a researcher wanted to gather participants from across the world, as Rall 2017 explained, you could create a series of clusters in a variety of different cities and then sample from within those clusters. One final sample method to be considered is non-probability sampling method, which is convenience sampling. In convenience sampling, the researcher gathers a sample from a group of people that are either geographically close to them or easily accessible. In some instances, this could include access via listservs, social media, or physical proximity. This is a very cost-effective manner and can also help to have a low dropout rate. To add to your own professional and academic development, I've included 5 references here that I utilized to create this short presentation. I hope this short presentation has given you insight and understanding into experimental design and how you may use this in your future studies as a doctoral student. I know when I was beginning my doctoral studies back in 2015, I was very confused and in the dark about the different methods available to me outside of just qualitative versus quantitative design. In this presentation, we reviewed and highlighted experimental design, randomization, sampling methods, and applications of this design. I hope this review was helpful. I now welcome any comments or questions you may have.